All right, all right. Welcome, everybody. This is a just-in-time stream.
Are you
Uh,
saying that because I just got here like 1 second ago? Sorry about that, Thorsten.
all good, all good. So I
It's as
was,
live as it gets.
yep, that's true. So yeah, thanks everybody for tuning in to another episode of Fermyon Live. So in this episode, Mikkel is with me, and we will look into building an rate limiting proxy with spin.
Yes.
So that's the
What is it?
plan.
What is that, Thorsten? What are you trying to achieve? Because I know you're the one who will be doing the coding, and I'm the one who will be asking you the questions. So maybe the first question will be, why do you want to build such a thing, and what do you want to use it for?
I think rate limiting is like a super great example for a non-functional requirement that may find its way into the let's say product backlog. Not in the first place, but maybe once you shipped your first version and you see it taking up a little bit and you see people hammering your API and you want to enforce some sort of access control on top of things like authentication authorization to maybe deal also with misuse of a public API endpoint.
Okay.
Yeah, so that's basically the idea. But instead of jumping right into the code, I thought maybe it's time to draw some squares and arrows to
Yes.
get everybody on board. Alrighty,
Mm.
let me share my screen. So let's move to okay. Let's move now. There we go. Not yet, almost. Have quickly to restart my window manager. Restart service. There we go. No, there don't we go. We don't go there. Let's try it the manual way. Okay. So you should not tinker around with your window manager a minute before live stream. Lessons learned. All right. Let's start by bringing in a couple of or some shapes over here. So obviously somewhere we have a user that is trying to send a request to an origin.
What?
Right.
Can you
Sorry.
just help define origin as a concept?
Yeah, so let's say there's some API endpoint somewhere, and because we are going to intercept from or that request from that flows from the user to the actual API, the API is often referred to as something or as an origin, right? Because we will add another like a component or system in the middle of that. So, and from the point of
Okay.
view of our spin application that we are going to write, the upstream API, we could also refer to it as that, but it's often called an origin.
Okay.
Okay, cool. So we will build a spin app over here, and I will make it a little bit bigger because we will add more, shapes
But it's
to
a
that
very
one.
small application, right? Like
It's a very
binary
small
wise.
application. Yeah, sure. It's just, to make it, understandable what's happening behind the scenes.
Yes.
So we have a request that goes there, and maybe at some point it goes there. So we will make them nice and aligned over here. No, we won't make them. No. Almost. All right. So we have we have a nice shape like this. Let's make that orange. So when it comes to rate limiting, it's pretty common that you have like a time window and you may allow your users to send like X number of requests in that time to the actual API. So at its core, we have to check is rate limit, let's say, exceeded. And that's why the spin app is so big, because we have to make this look nice, right? So we want to go to some data store, and I think we will use a Redis for that one. So there's a rate, let's say limiting store. So basically we will query that store, and we have two outcomes, right? So we say, hey, give me rate limit, let's say per client IP. So obviously you could use different circumstances that could be discovered as part of the request. So the client IP is like a simple one that we'll use for this example, but you could also, for example, rate limit by token, rate limit by the location of the user, by different circumstances, right? So if the rate limit is not exceeded, so in the no case, we forward the request to the origin, right? And at some point, we also track another API call, right? So that ultimately we will have some sort of counter that is grouped, that's grouped by the client IP, and that will increment. And we could use like a simple time to live in Redis to make that, being automatically being reset after our rate limiting window. But on top of that, there could be the case that the user has already exceeded the defined rate limit. So in that case, rate limit is exceeded. We return early with 429, indicating that the request limit has been exceeded. Yeah, there's one missing piece over here. We want to be a good citizen developer, so let's use this one. Let's say those are our application variables, and this must go that direction, like there. Let's say we load configuration, because we want to make that configurable from the outside, so that we could, rearrange the rate limit, that we could rearrange the time window, and yeah, so that it is, that it could be configured according to our needs in different environments. Yeah, so that's basically it. That's what we're going to build in the next, hopefully, 52 minutes.
Awesome. There's something in here that seems this to be kind of a reusable. That's maybe why you want to put variables in. Like I could plug this in front of many different places.
Yeah.
So are you planning on making it sort of like configurable and reusable in that sense? Or,
Yeah, I mean, ultimately, it's we'll compile it down to WebAssembly. So we could use that, or we could push that WASM module to registry and make it reusable by that. Yeah.
Yeah.
So yeah, but maybe you just have like more than just one API that you want to front with a rate limiting proxy like that one. So at least you want to make the origin configurable, right? To have the flexibility on that end.
Okay, cool.
Yeah, so that's the idea. I have prepared only a few things, and right now I think I have to, come on. I'm wondering, I know how I can do that. Mission control. There we go. Okay, so I've already created a spin application, and I will walk you through what it is, or how it differs from a file new from the file new experience provided by the spin new command. So I've chosen to write this one in Rust. So the spin toml is pretty close to what it normally looks like. I already created that like a table for the component variables, and yeah, besides that, it's the default spin toml. I updated the implementation of the sample, so added like a couple of macros over here to get rid of those squiggle lines, and said, well, it's not yet implemented, but there are some helpers that I want to use in order to speed up like implementing the end-to-end application. And those are mainly, to like let's say plumbing, right? Things that you
Hmm.
have to implement in order to, for example, take like this one takes all headers from the incoming requests and turns them into a vector of a tuple with two strings, which basically implements an into headers trait so that we could, have a nice or use the APIs provided by the Spin SDK for proxying the actual incoming request. And yeah, this goes on. So there are like a convenient conversion method for dealing with data that we retrieve from the Redis cache, and to construct the origin URL, because from the incoming URL we want to take the path and the query parameters if they are present, and attach them or append them to the origin that we configure as part of our application deployment.
And I would assume there would be headers and other things in the request.
Yeah, exactly. So we will take everything
Potentially.
from
Yeah.
the incoming request, like headers, like URL, like method, body, and forward that to the origin. Yeah, so these are just like convenience methods to make the librs a little bit cleaner when we open that once we're done. And the same applies for identifying the client IP address. So this could differ depending on the actual runtime you use for running your Spin applications. So for example, in
Mm.
SpinCube, it could depend, there could be different headers that you have to investigate or that you have to examine to find the client IP address, because that maybe it's your ingress or API gateway controller that injects those variables or those contextual information on a different header. For Spin, for Fermyon Cloud, it's the spin-client header, which gives you not just the client IP, but also the port if present. And this method, it could deal with IPv4, IPv6, with ports, without ports. And I don't want to make you and the audience look at me writing that manually during the stream, because you see there's some, pausing going on here. And for testing purposes, we fall back to 127.001 for yeah, to make it work when I test it on my local machine with
Yeah.
curl. Yeah.
Yeah.
So those are
I
the
do have one
helps.
question though.
Sure. Yeah.
Uh,
Go ahead.
you're not using any, are you using any libraries in your helper, or did you have to do all of this yourself? And
That's a good question. Let's bring up cargo.toml, because I indeed use one helper, two helpers on top of the Spin SDK. So Spin SDK and anyhow are there like for every new Spin app you create.
yeah.
I added already 30 JSON because I know we will use that to, store data in a JSON format in Redis. And I'm using the URL crate, so that's a common Rust crate to manipulate or inspect
Okay.
URLs. Yeah,
So you
but
don't, okay.
besides,
So I think one of the things I wanted to figure out is like, how much did you have to do on your own, or could you rely on some of those common libraries to make some of this functionality?
yeah, I
So,
guess there are even like more powerful crates out there that I could have used, but then I think it's like a balance between, okay, I want to talk and explain how to write something like that, instead of, hey, this is how you use the crate that's out there. So
yeah.
maybe it's a smarter choice to look into the more in the buy area of a make buy decision for real
Mm.
world product. So I'm more on the maker side right now to explain on the go what's happening.
Okay.
Okay,
Cool.
cool. So, first of all, we said we want to make this configurable. So, in Spin, we can simply specify variables as part of our application manifest, and those variables, we could pull them in from different sources. And I think the easiest one is when running locally, you can specify them as environment variables with a simple prefix. And yeah, so once we have defined those application variables, we grant our component access to use those variables, and we will also use that to define, hey, this Spin app is able to do outbound connectivity to our origin API and to our Redis. So for sake of demonstration, I'm right now running it locally using Docker, but you could also, go to your trusted cloud vendor, pick a Redis offering from there and use that one. All right, so let's define a couple of variables. So we have obviously the rate limit, which is a simple integer. However, variables are strings. So let's define, let's say 5, and let's say time window. So we want to enforce a maximum rate limit per IP address of 5 for every default for every 60 seconds, right? Our origin is required true. We will pass that as an environment variable when we start the application. And we have a Redis connection string, which we could, obviously it would be something like required equals true, a secret equals true, like that, right? But for the sake of demonstration, I will go there and say Redis connection string equals default Redis / localhost. Oh, I forgot the default Redis port is 637. Oh, that was the wrong 6379. Okay. So this is the comment indicates how you would configure the variable in a real world scenario.
Yep.
And this is right now for the sake of the stream. Okay, so we want to allow outbound connectivity to, first of all, to our origin. So we can use interpolation over here, origin. And we want to allow outbound connectivity to our Redis endpoint. Now, this is a little bit tricky, right? So my local Redis runs without any password or credentials, without any authentication. If you use a hosted Redis or like a Redis with that has a username and password, the connection string looks different, right? So you would normally have something like Redis host over there to compute the origin, right? Because the origin is like the value that I have for my local account over here. So I could right now reuse the variable Redis connection string, but if that connection string contains like your password or your username, you may have, you may extract at least the host and the port and compute the origin for that one over there.
So you basically want to split up the variable in multiple
variables. Exactly. I would split the variables. Yeah, that's right. Okay, so our component itself, that obviously needs access to those variables. And again, that's the rate limit over here. That's time window over there. Okay, and then we have the origin. And we have the Redis connection string. Cool. So now our component has access to all those variables, and now we could move on and start implementing the rate limiting proxy. Let me bring in my file explorer, and let's say we want to, like a real world application, right? You don't want to put everything into lib.rs. So instead, you can obviously create as many module files, or in Rust case, and in the case of Rust, it's called modules, as you want. So we add another one over here, we say config. And let's go to config rs, and let's say we want to have a structure config that consists of a public accessible origin of type string, our Redis connection string, which is also string, our pub rate limit, which is an U32, and a time window, which is an I64. And I decided to go with an I64 for the time window because Redis has a nice API for sending
Okay.
I64s there, so that streamlines it in the long term.
Okay, cool.
Okay,
It's funny that when
so
you have the Redis underscore connection underscore string as a string, it just like reminded me
yeah.
of the time when people actually uh, used types in the variable naming. But that's not
Oh
that's not
yeah.
why you're doing it. It's because it is a
No.
connection string. It's not because of the connection string.
Yeah. I think that was pretty common in C++ in the early ages of C, when I wrote C++, which is 25 years ago. Yeah, you always had like a M prefix for member variables. Oh yeah, dark ages. Okay,
Anyways,
yeah. So there's a public function. Oh no, let's scope that to the crate as well. Load config, and that will return a result. Anyhow, result go away of self over here. So let's say that origin equals. So now we use the spin SDK to load the variable using its name. This could obviously go wrong. Maybe I misspelled the variable or things like that, or messed things up over there. So I used the question mark operator to terminate early and return an error variant. But let's go with context and provide some information like error loading origin variable. Let's go there and paste this one, and then we take care of the Redis connection string. So this is the
here's what
Redis
may be a little
connection.
bit of a Rust newbie question, but sometimes there are various ways you can throw arrows when you try to unwrap or whatever you do in Rust, or the question mark operator, which is you're using with context. There's also expect. Is that because it's either a result or an option, or what's the difference in using either of those?
So unwrap will basically panic and terminate the execution immediately.
Yeah.
Spin takes care of that. But with context, so variables get returns and result of an error that is not an anyhow error. And with
Ah,
context, I can say, hey, come up with an anyhow error. And by the way, set the error message to error loading origin variable. There are many ways how you can, construct errors or turn things into
yeah.
errors. We will use additional ways in a second, just
So
to
so okay, so the with context method aligns with it's an anyhow arrow being thrown by the SDK.
yeah, that comes from the anyhow crate. That's
Okay,
correct. Yeah.
cool, thanks.
Yeah. So there's a rate limit. This is rate limit limit limit, and last but not least, we have the time window. Right, so this is time window, and this becomes time window. So now we have all variables as strings in context. You know, I would prefer having like additional checks, like for example, if origin is empty, we want to also return an error. And now we could use bail, which is a macro provided by the anyhow crate to immediately return an error and say, hey, origin is empty. And the spin runtime handles that error. If I, in my librs I will later just use the question mark operator, right? So that handler also terminates early with an error, and the spin runtime handles that and returns back an HTTP 500.
Okay.
So let's roll with that and say if
And
Redis
sorry, but the origin is empty will be put on standard error, right? So you will be able to see that in your spin logs.
that should be that should be written to standard error, which is also forwarded to
Yeah.
the output. Yeah.
Okay.
Redis connection string is empty. Oh yeah, let's make this. Okay. So for rate limit and for time window, things are different, right? So variables, because they could be injected by, methods like, for example, environment variables, we receive them as a string. So we have to convert them into the proper data types that we want to use. And we can simply do a shadowing over here. So redefining the same variable. Let's say rate limit equals rate limit parse into, and I think the rate limit was a U32.
Yeah.
And again, we could say with context, invalid rate limit provided or specified like this. And again, for the next one, let's copy that and say we have the time window, and this one is an I64.
Oh, you need to change the rate limiter before pass.
Yeah, thanks. Time window. Okay, now we have all data strongly typed, so we can simply go there and say, okay, self origin Redis connection string, rate limit, and time window. Oh, what's that mismatch type? So I messed up. Did I mess up the types? U32, I64. Let me check. Oh yeah, I forgot something. I forgot the question mark.
Okay. So it's
Because
basically
it's
just a
still a
result of the string.
result.
Yeah.
Yeah, it was still a result, but right now, the squiggle lines are gone there.
Imagine
So
how many times a day a given person writing Rust code runs into that thing. But it's super nice. I've enjoyed learning those result and options based
yeah.
return types in Rust. It makes a lot of sense to me, even though they're a
Yeah.
little bit hard to battle sometimes. But
Yeah,
that's
they're hard to battle. Not hard to battle, I think hard to master, because
yes,
there is like
yes,
that method that you could use to turn an option into a result, and the other way around, and
yeah,
negotiate everything. And remembering those, I think memorizing those is the hard thing, because
yeah,
I think conceptual it's super great to have those
yeah,
powerful enums that you can use.
yeah.
All right. So with that, we can move on to actually implementing our application. So we can right now say we want to load the config using our config load config method. And this again returns right now a result of config. So I can simply go there and say, hey, question mark. So if there is an error loading the configuration value, my app will terminate with an HTTP 500.
Yeah.
So with that in place, we use one of our helper methods to pull in the client or to get the client IP address from the incoming request. So helpers get client IP, we pass the request over there. And I think that's simply returning a string. Yeah,
Yeah.
okay. Okay, so now we have everything in place to start implementing rate limiting. Oh, no, we have to open the connection to our Redis. So connection Redis open using ampersand config Redis connection string. And we have to construct a key because the intention is we use the set method provided by Redis that allows us to specify the TTL for that value that we want to persist. So, that enforcing that timed rate limit is something that Redis does for us, and we don't have to care about that at all. That's the nice. That's why I decided Redis is a smart choice as a
Oh, okay.
rate,
Yeah.
rate limiting storage. So we have to compute some sort of key that is identifiable, right? So we say let key equals format over here, and let's say rate limit, and bring in the client IP, right? So we expect something like rate.limit.127.0.0.1 being the key. And we could now go there and look in Redis. Hey, do you have already some data at that key? Because if there is already a count for that particular client IP in that with that time or in that time window, we want to simply increment the value and store it back, and then check, hey, is the limit above the defined rate limit? Then we return with the error code, and otherwise we forward the request.
Okay.
So we're looking for the count, and the count is an unsigned integer over here. So we say, oh no, let's go like that. First, we load it. We load it from Redis. So let's say count equals connection. Give me everything at the position key. So this returns a result because there's network in between the spin app and Redis,
Yeah.
right? And it could go wrong. So we can say unwrap. So usually you don't want to do unwrap, but in that case I say, hey, unwrap. So if it worked, I get back the value. If it failed for whatever reason, I wanna go away. I wanna use none.
Okay.
Right? So because get returns a result with an option. And,
Okay. Yeah.
so we unwrap that one, we get an option with a potential payload. If things went wrong, I will simply want to receive a none, meaning this is basically right now an option of a vector with U8 in it.
So you've decided to basically say that the scenario is that if your Redis goes down, well, you might actually run into an issue with setting up the connection even, right?
Yeah, that's true. That's true.
But for the matter of sake,
Um,
what we're trying to do is just isolating this particular thing. If Redis goes down, you're basically taking the rate limiter out of the equation and keep serving requests because you
yeah,
identified the client as someone who's not been rate limited.
yeah, we could like, for example, uh, obviously if Redis is down, it will right now terminate over here. So we
Yes.
could optimize this one to pass even if Redis is not there, or immediately forward the request, right?
Yeah.
If let's say this get call so this works and the get call fails, uh, it will serve requests because we will right now implement like, okay, take this U8, convert it into an integer value, and increment it by one, or start by one if you don't have a value, right? So
Yeah.
yeah.
Okay. But we won't have
Okay.
anything to do with that value unless we can store it in Redis, right? Because the next time a request comes in, there's no session in memory or something like that we have in Spin, right? So we have to externalize the state somewhere, which
Exactly.
means there's a little bit
There's
of
no.
a, yeah, we
Yeah,
need Redis or
there's latency between like the app and obviously the data, the persistence layer. I mean, for Fermyon Cloud, for example, we have different key value, or we offer key value store, which is in the same, like, that's co-located to the app, let's say it that
yeah.
way, which is super fast, right? That may lack things like taking care of time to live for a key, but that's
Mhm.
something you could also implement by simply, taking the UTC timestamp at every invocation and using that to roll your own TTL mechanism. Yeah.
Yeah. Yeah. And there's even something about the key value interface that Spin has and consistency guarantees and things like that you also need to take into account. But yeah,
Yeah.
pick your data store very purposefully and with caution.
Yeah, that's true. All
Uh,
right. So yeah, I will again use shadowing, so redefining the count variable. But right now, I said, hey, I want this as an U32, so I say count. Um, and now this is like what we talked about earlier, right? All those great methods provided by Rust for interacting with, in that case, an option of something. So count is in line 18, so one line above over here, defined as an option, or it
mm,
is an option of evacuate. So if there is a value, you can say, hey, then move on, right? So then take the value and say, well, try to construct a string from that byte array from UTF-8, and this is well, yeah. So IntelliSense is getting into my way from time to time because I zoomed in that much.
I actually think
Okay,
IntelliSense is a Visual Studio thing, isn't it?
I don't know. I don't know. Whatever.
But I know what you mean.
Yeah, that's good. That's good. Okay. So we try to take that byte array, if there is some, right, and convert it into a string. This could also fail. So this also returns a result of string.
Hmm.
In my case, I say, well, if the operation was successful, give me this again as an option of string. If that fails, give me a none value.
Yeah.
And this is like what we were talking earlier, right? Those tiny but powerful methods that you can chain together in order to make that code look super nice.
Yeah.
So, and once that finished, we want to use a simple we could right now, this is an option of string. So we could also go there and use the parse method again on value colon parse. But I think I don't want to go that much off script. I'm already off script, and
That's fine.
yeah, I basically did a super simple trick over here, and I said, well, use 30, expected as JSON, and pass in ampersand val over there, and that could be an okay. And okay. So this is basically me saying, hey, 30 JSON, there's some string, try to convert it into an U32, but yeah, I think that it's smarter to go with val dot what's well dot parse, and I think let's try that.
And this is where you're going to look forward to the code review and asking someone when someone starts asking you for doing it the other way, and then it's like, let's bike shit on this.
Yeah, I could imagine Ryan already sitting in front of the stream and saying, but
He can chime in the chat if he wants to.
yeah.
Ryan being one of our colleagues at Fermyon, for those who don't know.
So we try to convert the string value into U32. If we receive an U32, we want to increment it by 1, right? So if no value is there, we end up with a 0, right? So we want to say, hey, this is the first call. If however maybe that particular IP already sent 2 requests to our endpoint, we end up with a 2 over here. So we want to increment this also by 1. And if something went wrong, right? If I, for example, got an empty byte array, if the byte array is not an integer, if something, did not work as expected, I want to simply return 1 and say, hey, this and this is where it not. Yeah, this is correct. String into U32 and mismatch type, and it says that was me going, it found an option of this one. Expected option. Okay, so it's Okay. I think I can simply fix it by this, consuming it. Okay. That was easy. Um, all right. So yeah, we end up with one for the first invocation, and for every, upcoming invocation, this one will be incremented by one.
Yeah. And we're
Okay.
okay if anything goes wrong in there to just default back to one.
Yeah. For the sake of this demonstration, yeah,
Yeah.
we are good with just returning one in that case. And now it's time to implement the rate
So
limiting
just just
itself.
just to recap, so count basically means how many requests have we received within the current time window? That's what we need to count for a particular
Yes,
client IP, right?
correct. That's precisely the definition.
Yeah. Yeah.
Okay, so next we implement our rate limiting, and that's as easy as saying count if count is bigger than config dot rate limit. If that's the case, we want to return okay, no, okay with response new. It's first the status code is the first argument, and say too many requests. Try again later. Okay, so that was the easy branch, right? So we said, hey, oh no, we have to store it first. We still have to store the updated value, right?
Yes.
Let's say we have that count, yeah. So I start with the match expression, match count, and because in Redis we can specify the TTL of a key when using the set function. However, this is super easy or super convenient for writing or storing a value at a given key for the first time.
Yeah.
Without special treatment, that would and setting the same key for the second or third time would reset the TTL. So we have to construct like parameters that we forward to Redis as part of the set function call, and those differ if the count is one or higher than one, because we don't want to make the second or third invocation reset the time window. We want to, have that TTL tick down to 0 and then wipe the value again from Redis. So basically, it looks like this, that we end up with.
But TTL would be how do you make that? So you're not, how do you make, well, let's go through this. I need to
Yeah,
understand the
sure,
whole
sure.
time window thing, but we'll get there.
Yeah, sure. So what should I explain?
You write your
Or
code, then we'll get back to
okay. That's nice. Okay.
that.
That's nice. Okay, so the idea is what is over here? Yeah, there's a comma missing at the end of this line. Okay, so let me also add another, let's say connect. So Redis execute the set method, and then we pass in params, all the params. Right. So this is the idea. We want to construct the parameters that we want to forward to the set method. And yeah, for both variants, we have a Redis parameter of type binary. I call the variable key, right? Yeah. Okay.
Mhm.
So let's say key clone into no, not body, into bytes. So this is obviously the same for both. Next, we want to say
And that is
we want
basically
to
going to be the key inside of Redis as well. So
exactly. This is basically rate.limit followed by
yeah.
the IP address. Next, we want to set the value Redis parameter. It's also binary data, and we have to come up with value. Let me say let value equals 30 JSON to string to string. Man, I could simply turn I could turn that into a string as well. That's easier. Count. Can I say toString over here? toString. Okay. Okay. So this is value clone. Oh, then we could. I think it's more readable to say count toString into bytes and simply go there, paste it over here. Okay. So up until this point, both parameter arrays are the same, but now they start to differ. So we have a Redis. No, we have a Redis. I'm missing the comma. That's one. Redis parameter binary. And we can say, hey, Redis, this key will expire. So X is the operator for that. To owned. And then we say to into bytes again, into bytes. And now we have to pass in the time window. And this is why the I64 was is so convenient, because there is an int64 method over here, and I can simply say config time window. So I specified the default value to 60. So this tells Redis, hey, this key with its value will remain in Redis for 60 seconds. So setting requests with or setting a count or a key for a second or third time would reset the expiration again to whatever the time window is. So instead, we can say Redis parameter, another binary, because we want to provide another special operator from Redis, which is keep TTL to owned into bytes. And this tells, hey, there is a TTL defined on that key, and that's ticking down. Don't touch it, right? Update its value, but don't touch the TTL. So this is basically us updating the rate limit per client IP address in Redis. Okay. So there is we could do one more thing. So we configured that, we returned this, but we usually, as a consumer of such an API, you expect like HTTP response headers telling you, hey, you have, I don't know, sent 4 out of 5 requests, and the limit will, be reset, or the time window will remains active for that amount of seconds. So we can say TTL. We can also ask Redis for the TTL of a specific key. Let's say params equals ampersand over here, and then we say Redis parameter binary, and we simply take the key, clone that one, toString. Now we can immediately turn it into bytes. Okay, we say, hey, I want to get the TTL for that particular key again. Let TTL equals connection execute, and the function to get the TTL is called TTL, and we pass in the TTL params from there.
Okay, so we're basically getting the TTL of a given key inside of Redis at this point.
Exactly. And this is right now a Redis result. It's a result of a vector of Redis results. So we can unwrap over here, and then we can use one of the helper methods that I showed earlier. So helpers, I think it's called, get I64 from Redis result, and I pass in TTL over here. And we can say, or some null, or some null. That was the wrong magical method. No, this is not working. Let me quickly check what my method expects. It expects just one. Did all. Okay, so let's say ttl.first, because that's an vector, so I grab the first value.
Okay.
If that is there, then I say, hey, go there, then with the value, go to the helpers function and call the get this, pass in the v, and unwrap it. Unwrap it. Yeah, because if there's something went wrong, I said, hey, the time window will be expired, right? Or is already expired, and I return 0. Okay, so now we have the TTL. So we could use, instead of this one, oops, we could say.
And you wanted to use the TTL to add it to a header, right? Inside the.
Exactly. Next, we use response builder instead. That's nicer to do it like this. Okay, response builder. Yeah. 429, and then we can simply say header x rate limit and pass in format rate limit. So this is us basically telling the user, hey, there is a rate limit of X amount of X calls on that API.
Yep.
And I think we know how many requests he or she sent, so we can simply say, oh, I messed up did I mess up the brackets? No, that looks good. Okay, so next is a header of X rate limit, I would say consumed or used. Consumed. Again, that takes a format, and that simply gets the count. Where's my count? I messed up something. Body build. Okay, now it's heavy.
Yeah.
So now it's heavy again. Okay, and now we pass in the reset. That's often called reset, and that is basically the TTL. What else?
What did we set the TTL to when we created the key? So what's the?
Oh, that's 60 seconds.
Okay.
And basically this is the remaining, telling the user, hey, you have to wait that amount of seconds, and then you will again have like whatever defined in rate limit.
Yeah.
So consumed. So we can also like do some convenient header that's also quite common is rate limit remaining.
So you don't have to go and do the math yourself.
Yeah, but it's super convenient to expose that as well. Okay, so those are common headers that you return no matter if the call was successful, was succeeded, or was passed to the actual origin, or if you terminated early.
Yeah.
This is a number. I'm just double checking if the borrow checker will blame me in a second from now. Okay, so this is the easy or not the easy part. This is basically okay. The user or that client IP exceeded the rate limit. Now we have to forward the request to the origin. So first we want to construct the URL. Let's say origin URL.
So I assume in this case your rate limit remaining would always be 0.
This one, why would it always be 0?
If you've exceeded.
Oh yeah, yeah.
Anyways, I understand the intention. This is good examples. Let's play.
Okay. Yeah, sorry. I forgot about the if branch. Then I was okay. 5 minus.
You can
1.
move it down in the next. in the next section if you want. Yeah. Anyways.
Okay, so we build the origin URL. This is CFG origin, and now we have to pass in the request URL of the incoming request, which is basically request.uri. So the helper method takes care of that. That could go wrong, and then we terminate early with the question mark operator. And let's say we call it origin request, and we use the request builder to say, create a new, oh, we want to let origin method. So creating a new that wants the method, origin method, and that wants the origin URL over here. And now let me check. We have a headers method, right? Headers, yes. And I have that helper method that says clone incoming request headers. So it's basically iterating over all the headers specified on the incoming request and turns that into something, a vector with a tuple that implements the into headers trait that is specified in the Spin SDK for Rust.
Yeah.
Okay, so now we have the headers, we have the method, the URL, the body is still missing. So we say body, we can say this is request into body. That, yeah, obviously it consumes it internally. There, we could roll with raw WASI to use streaming over here, but again, for the sake of this demonstration, I think it's okay.
And there's a bunch of things in terms of, you mentioned streaming now, but how HTTP basically works in terms of not simply being able to clone the request. Like you have to handle each individual pieces of the whole request, like the URI, the headers, body, and so on.
Yeah. Okay, now we have a request. So this is a same type as we received from the Spin SDK as part of our handler function, but we could use the outbound HTTP capabilities provided by Spin. So we can say at some point, well, we hope to get back, let's say, origin response. And this is a response. We have to type that. And we use the send method provided by Spin SDK HTTP module. And we say origin request over here, and we await that. There's network in between that could fail. So that's why the question mark operator is there. So now we have the request, right? The response. So we could simply do okay origin response over here to simply return whatever we received from the origin. But lazy me, let me copy those 6 lines. Let's paste them over here because we want to modify the headers on the way out again. Expected one argument header at this and this. Yeah, I think that's correct. Origin response header. Oh no, that's a getter. That's a getter. I think there's a set header method. Yeah. Okay, there we go. So on the way, sorry. On the way out, we want to modify the headers again. What's going on with my IntelliSense over there? Oh, my code over there. Set header. This is set header. This is set header. And this is origin response.
There's a header 1, 2 lines up you need to change as well.
Thanks. Okay, now let's get rid of those blanks. have been faster if I wrote that from scratch.
Okay.
Okay, we're getting there.
Uh,
There's something that is missing this and cannot borrow origin as yeah, that's right. This is immutable by default, and because we manipulate the response headers on the way out, we have to mark
yeah.
this one as mutable. And with that, we should be done. So let me check once again. So we let's go through it once. So we load the config, we grab the client IP address, we open the connection to Redis, we compute a key, we try or we look up the count for that particular client IP address in Redis. If we found something, we increment the value by 1. If we found nothing or something goes wrong, we say this is the first invocation for that of that client IP. Then we have to match the count, because for the first time we want to set the expiration. For every upcoming invocation, we want to use keep TTL over here so that only the value is updated. And then we execute the set method. Then we say, okay, there's a nicer way of doing that. I think this is nicer. Okay, then we say we want to read the TTL for that given key again. So this is basically the ticker that goes down and says, well, your quota will be reset in that amount of seconds. So if the count is bigger or higher than the configure rate limit, we return a 429 with all the rate limiting headers. Yeah, and otherwise we compute a new request and send that to the origin using all the request circumstances that we found. We await sending that response. We capture the response, modify the response, and add those rate limiting headers as well. Cool.
So the so it's really not a sliding window we have here, right? I don't know if you have intention to do that.
It is a sliding window.
Well, but it's based, the window closes when the TTL expires, right? You don't reset the
when you send the first request, so we say, hey, you have a count of 1, and this, in 60 seconds, Redis will automatically wipe that key. So in 61 seconds, you're again down to 0 calls. If you send more requests in the same time window, your count will increase and again reset after like the remaining time. So it is basically like a time window of 60 seconds. But starting with the first, you're right. Starting with the first occurrence.
So we're not, again, like the way that I understand what a sliding window is and whatever, that doesn't matter. But it's not like saying in the last 5 minutes you can send X amount of requests. So I think the scenario being like, let's say within 60, the way we have it now, let's say that let's say I only get 10 requests, just to simplify the case. If I send 10 requests in the first second, I have to wait 59 seconds to be able to send another 10 requests.
Correct.
Let me think through this because I might be off here.
we can let's
okay, we need to bring in, well, no, let's
drive that home. Let's bring that home. We get there. So let me check. How did I call
I think you know what I'm trying to get to here.
Yeah, I know.
Is it like in the last 60 seconds, or is it like for every 60 seconds? That's like, when does the window slide?
The window starts sliding with the first request.
Yes.
Yeah, it's the same mechanism that GitHub uses. That's the easy answer.
And we would trust that to have someone actually thought that through. That's
we
fine.
we can try. We will try. We'll see. So let's put that in the background for a second. So I have an URL, an API deployed to Fermyon Cloud, right? That is not this one. Um, Cloud apps list. There is sample API, info sample API. Okay, there we go. This one. Okay, curl this one. API products. So this is
I'm just
GQ.
going to put the question up here because that's a question that we had. It's not a question coming in from the chat. So if anyone can help.
So this is basically a sample API deployed to Fermyon Cloud, providing like plans and with their, name, their scientific name, and which plant family they belong to. No, I'm not into plants. This is generated data by some random data generator service. But
Nice.
I mean that's the API we will front with our rate limiting proxy. So let's say we have first. Let's do a spin build and double check how this is good. This is nice. So no build errors. That's good. Let me cut spin toml for a second again. So rate limit, we have a value. Time window, we have a default value. Origin is required. That's missing. And the red is, oh, yeah. Okay, so let's check if Docker PS. So Redis is running. Okay. And we can set a variable of origin equals to this one.
Mm-hmm.
And do a spin up over here. There we go. Okay. So new terminal. Let's make this like that. And let's do a curl. We aren't interested in the data at all, right? So let's say localhost the API /products. That's the endpoint. So we want to dump all the headers to standard out, and the actual response payload, we forward that one to dev null because we are only interested in seeing the headers. And now, fingers crossed. Let's see. There we go. Rate limit 5. It's 60 seconds, 4 remaining, 1 consumed. Well, let's clear it. Let's do it again. Consume 2, remaining 3. Reset in 51 seconds. And so on and so forth. Consumed 3, consumed 4, and now I consume the last one. And for the next request, we expect a 429. So we get back consumed. Okay, I'm still incrementing the count. But if I stop, if I just invoke it like this, I see that we get back too many
Oh, you're still
requests.
incrementing the count. Yeah,
Yeah,
okay.
I am.
That's yeah,
But
that's because we don't. Yeah.
yeah, so if we bring up, how's it called? I think it's Redis Inside. That's a Redis client I have on my machine. And let's get rid of this one so the tiling window manager is happy. We can look at all keys. Filtered. Search. Oh, oh no, is it? Yeah. I'm able to call the API again because the minute was over. So there we go. We see in 54 seconds. Right now we have 3 invocations. And if I refresh right now, you can see the TTL being automatically decremented by Redis, right? And in 30 whatever seconds, it will be, the limit will be gone, or the quota will be gone, and we will be seeing requests again flew through the system. 20 seconds to go. Okay, so this bug, we definitely have to fix that one. Okay, so now if I refresh right now, I expect the value to begin again. Oh, no, TTL1. Okay, now it's empty. And refreshing this view is basically, there's no data in Redis anymore. So let's check so where's my bug? Yeah, because we are already incrementing over there. Yeah, we set it, right? That would mean we could, instead of incrementing it over here, we could remove that. And we could say let new yeah, we can if we can come up with a new variable, and I try to come up with a meaningful name. Let's no, let's call it incremented count. Incremented count equals to count plus 1, like this. And we look at incremented count right now. Incremented count. And over here as well, incremented count. Okay, so this is what we basically store. However, if the incremented count, but it's yeah, okay, incremented. The semantic is there would be a way easier fix to do that, you know. Let me undo what I did. So the easier way to fix that is basically saying if we exceed that one, we say, hey, you consumed rate limit.
Yeah.
Yeah. I mean, technically, yes, the rate limiting proxy handled more requests, but we forwarded. So maybe it's, yeah, maybe it's something like, proxy it, something along those lines. Yep. And oh no, that was a spin variable. Yeah. Dash dash build. Yeah. Oh, port already in use. Okay. FG.
It's open somewhere.
Yeah, it's open somewhere. Oh no. There it is. There it is.
Ah.
Build. Okay.
Build it.
And now the curl request, but the other one. Proxy at 1, proxy at 3. Yeah, it's curl is not sorting the headers in
Oh, wow.
SQL.
Yeah, that's confusing. Okay.
Yeah.
So you proxied 4, you have 0 remaining, rate limit 5, proxied 5, and now you. Yes.
We get
Okay.
back the same. And if we,
What is the rate limit remaining now? That's a weird number.
Oh, yeah.
Anyways.
Yeah, I know what it is.
Yeah.
Yep.
But I think we get the gist of what we're trying to do, and getting some of that information correctly is, to be caught in code review.
No, the problem is that Rust.
I'll maybe write a test.
Yeah, maybe write a test that I do. The problem is this one, and this is an count is an U32, and then they start over, right? Because we go beyond that. Is that correct? Yeah. That's weird. The count is higher than that. Yeah. Yeah, because it's unsigned, right? If it
Yeah,
is signed, then it would go below zero, and so it starts at the higher border of U32 again and subtracts it
yeah.
that way. Yeah,
Anyways,
or not.
I think I found something about the whole sliding fixing window. I think the scenario is basically if you if the way that we've set this up was like 60 seconds and 60 seconds and 60 seconds, so basically every minute you get another
Yeah,
5 requests, you can within 2 seconds actually do 10 requests if you hit the end of a window and the beginning of a window, right?
sure. Yeah, yeah.
Which means that
Usually,
you don't have like you don't have a smooth sort of rate limiting. You have like very,
yeah,
I don't know what you call that type rate limiting. Anyways, I found an article where someone was explaining in terms of how what the actual, how you should take in account for how many percentage into a given window you are and sort of move it
yeah,
along. So, but
yeah.
anyways,
I,
it's a
I
detail in the
think.
whole.
Yeah, I think what GitHub does, they on top of having a rate limit per minute, like this one, they also have an hourly limit, and I think
Oh, so they smoothen it out that way. Yeah.
yeah,
Okay.
yeah, yeah,
Okay,
yeah,
cool. Well, awesome, Thorsten. I mean, it's there, it works. A lot of Rust development was happening.
yeah.
Really great scenario.
Yeah, I think it was. I thought about, having more code in the first place and explain it, but I think it's worth understanding or illustrating that you could approach a spin-up like every other project, right? You can
Yeah.
use the patterns, you can use the idioms that you're used to use in whatever language you choose. We now went for Rust because usually you want a proxy like that to be super fast. Um, TypeScript, different idioms, same approach, treat it
Hmm.
as a regular application and go from there.
Yeah. Great. Well, thanks, Thorsten, for doing this, walking us through everything and, uh, trying to answer all of my questions and comments along the way. And thanks everyone who watched, who was watching our stream. We hope you found some value in this, or at least, had fun along the way. Very educational. Yes, thank you. Thank you for that. I
Thanks. Yeah.
also learned a bunch of things. Cool.
Alrighty.
We expect to set up another stream next week. Yes, maybe 1 week, 2 weeks, maybe.
Yeah, I think right now we
Maybe
are in
two
a
weeks.
2 weeks cadence right now. Yeah. Yep.
Yeah.
Yep.
Keep a look
But
out in our Discord channel, or take a look at, I'm trying to find the Discord link here, maybe here somewhere.
I was just trying to do the math, right? Because that's 2 weeks, yeah, and then there's conference season, right? There's
Yes, there's a
Wasmayo
lot
happening,
of conferences that
Barcelona,
will come up.
KubeCon, and so on and so forth. Yeah.
Great.
Awesome.
Well, see you, Thorsten. Thanks
See
everyone
you,
for following
Mikkel.
along.
Thank you. Bye bye.
Bye.